Hello, good afternoon everyone. I hope everyone's doing absolutely fine. Welcome to day number 25. That's 9th of May 2025 everyone. So today we are about to start the last chapter of your bridge course curriculum, that's units and measurement. So I hope everyone's fine, everyone's doing well. If yes, give a thumbs up and let's get started with units and dimensions. So are you really excited in order to understand the basics of physics, which is nothing but units and dimensions? Because you know that anything you are going to be measuring, any physical quantity if you are going to be measuring, you require units associated with that physical quantity. So now if everyone is observing me right now, they can give a thumbs up. I hope you are ready with this chapter. Okay, hello, good evening, Sanjana. Okay, so let's get started. Yes, Murli, good evening. So let's get started with today's session. So before we start, we need to write down the name of the topic, and the name of the topic is units and measurement. So now if you can recall, in the previous week to be more specific, when we started vectors, I mentioned already about physical quantities, isn't it? That those quantities which can be measured, and physical quantities can be classified on the basis of two aspects. One is on the basis of direction, another one on the basis of its magnitude, isn't it? So now you can see that you can consider the same thing over here. All the physical quantities which are used to describe the laws of physics are known as physical quantities, and those quantities which can be measured over here, isn't it? And you can classify them on the basis of direction, which we have already discussed in the previous chapter, isn't it? This was already being discussed in the previous chapter. On other hand, over here, if you're able to see the physical quantities which, so you can say that scalars, you already know scalars, everyone. Those who know scalars, they can give a thumbs up. Those who knows vectors, they can give a thumbs up, because we ended our discussion yesterday on both vectors and scalars, isn't it? So you can see over here that the physical quantities which have only magnitude but no direction are known as scalar quantities. Example, mass, density, volume, time, etc., which have already discussed. And the next is on the basis of the direction aspect which you can classify in a physical quantity. It's going to be vectors, those which have both magnitude and direction and obey the laws of vector algebra. We have already discussed about the laws of vector algebra, law of triangular addition, polygon law, parallelogram law, isn't it everyone? So are known as vector quantities. So example, displacement, force, velocity, and lot of things we have discussed about vectors, isn't it? So now I mentioned that there is another aspect by which you can classify the physical quantities. What is that everyone? On the basis of their dependency, isn't it? So on the basis of the dependency, there are two classifications. You can classify the physical quantity in two further aspects. One is fundamental or base quantity. So you can write it down over here, that those quantities which do not depend upon other quantities from their complete definition are known as fundamental or base quantities. So we'll discuss about these fundamental quantities, isn't it? So there are 7 existing fundamental quantities. I am having a table associated with that. I would like to show it to you all in the upcoming context. Okay. Similarly, the next classification over here is known as derived quantities. So what are these everyone? So these quantities which can be expressed in terms of the fundamental quantities are known as derived quantities, isn't it? So now these quantities can be derived from the fundamental quantities. There are 7 fundamental quantities and there are several existing derived quantities. So you can derive all such quantities from those fundamental quantities. That is what they are trying to say. Okay, so now you can see that what are the examples: speed, isn't it, volume, acceleration, force, pressure, etc. So over here we are not classifying the form of vectors and scalars. Okay, we are having two aspects, two classification on the basis of the dependency. One is fundamental quantity, another one is derived quantity. Okay, and these are the units if you can see over here. Okay, everyone got it? If yes, give a thumbs up. Then we are going to be proceeding. We have to know about what these fundamental and derived quantities are. If yes, give a thumbs up and you hit the like button. Okay, everyone. So now the next is going to be, so you can see that there are some interesting points over here. You can see that physical quantities can be also classified as dimensional or dimensionless and constant variable. And you can see that some physical quantities cannot be completely specified even by specifying their magnitude, units and direction. So these quantities are known as tensors. I think so I've already used the term tensor, isn't it? If you can recall, I mentioned that about moment of inertia and stress, isn't it? There are two. One example is being given. Another example, you can also write it down it as stress. Stress is another example. Okay, so these are known as tensors. Okay, so you cannot say them to be having magnitude, units and direction over there. So that's what is known as tensors, everyone. So now you can see that we need to understand the system of units over here, isn't it? Then only we can easily understand the fundamental, what do we understand by fundamental quantity and what do we understand by derived quantity. Because I would like to say you that if I'm measuring any parameter, let's say I'm trying to measure displacement, acceleration, you know that in a vehicle, if you are going to be driving a car, I believe that everyone is acquainted with driving, but I should not be recommending you because you are below 18, isn't it? So you know that the speedometer is going to be measuring the speed of the car or speed of the two-wheeler, isn't it? So obviously you can see that there is going to be some unit associated with it. So that unit is known as going to be that derived unit or fundamental unit, which we are going to be discussing in this chapter of units and measurement. So you can see over here that now in order to understand the units, we need to understand system of units, because every countries on earth, they are having their own system of units, which we are about to know it right now, isn't it? So you can see that system of units, FPS or British Engineering System. FPS means foot pound second, isn't it? So obviously in all the systems, the three basic physical quantities are going to be mentioned. The three basic physical quantities, I will write it down. In all such systems, if I am going to say, there has to be three basic physical quantities which they have to be mentioned over there. One is the measurement of mass. Next is going to be the measurement of length. And last but not the least, the measurement of time, isn't it? So these three terms, these three physical quantities are going to be measured in all such system of units. So now you can see this is a very easy chapter, everyone. So that's why focus here. This is really scoring, trust me. Okay. Lots of questions are being asked on dimension analysis. I believe that everyone should be following this and they can score the maximum marks from this context whenever they are going to be asked in JEE Main Advanced. Even in JEE Advanced, question comes from dimension analysis, okay? And JEE Main definitely will be getting 2 to 3 questions from this topic, okay? So now over here you can see that British system, what is it all about? The length, mass and time are taken as fundamental quantities and their base quantities are foot. You can write down foot, pound and second. So foot is being denoted by the short form of FT, just like the way it's being shown over here. Pound is going to be measured in LB and second in this. I think so everyone knows about the representation of pound, because most of the people over here, they must be a regular watcher of WWE, isn't it? So over here the weight of the wrestlers are going to be measured in LB, if you can recall. Okay, you might have seen, everyone must be watching that and they have been following the trump cards games, isn't it? So now over here you can see that CGS or Gaussian system, that's going to be the next type of system over here. So you can see that in this system, the fundamental quantities are going to be once again length, mass and time, and the respective units are going to be centimeter, gram and second. So that's why you can try to read that short form as CGS, denoting centimeter, gram and second. Very good. Okay, if you have scored 568. Next is going to be MK system, that is known as the meter, kilogram, second system. So you can see that in this system also the fundamental quantity once again the fundamental quantity has to be what, everyone? It has to be length, mass and time over here, and the fundamental units are meter, kilogram and second respectively. So we are having three systems in synopsis, I am saying till now, which we have studied so far. One is FPS, also known as the British Engineering System, where we are going to be using mass, length, time as our fundamental unit, isn't it? So based upon it, you can write it down it as FPS, isn't it? Now foot pound second, next followed by CGS representation, that is centimeter gram second, and last but not the least over here, that is MKS system, that is meter kilogram second over here. Okay. So now based upon the situation, now comes the most important part, which is very, very important over here, everyone. So that is the international system, because in our calculations, in our JEE main advanced curriculum, we are going to be using SI system itself for our calculation over here. So what is it going to be? You can say that the system is modification of the MKS system. So it's also known as the rationalized MKS system. Besides 3 base units of MKS system, or 4 fundamental and 2 supplementary units are going to be there, also included in the system. We will discuss about this supplementary units in the upcoming context. So these are your 7 fundamental or base quantities. This is very, very important, everyone. You can write this thing down. This are your 7 most important. You can say that this is 1000 stars worth, I will say. So this is what your 7 fundamental units is going to be. So what are we having over here? That is length, mass, time, temperature, amount of substance, electric current, luminous intensity, isn't it? And that's what it is, isn't it, everyone? I hope it's clear. If yes, give a thumbs up. Those 7 units over here: length, mass, time, temperature, electric current, luminous intensity, amount of substance. So what are the units over here? The units over here, length is going to be measured in meters, isn't it? And the symbol is very, very important. The symbol is going to be M. Mass is going to be measured by kilogram. The symbol is going to be kg. The time is going to be measured by seconds, and the symbol is going to be S. Temperature, once again, it's a fundamental quantity, so you have to write it down over here as Kelvin, and the symbol is going to be K. Electric current over here, electric current is going to be measured in ampere, isn't it? So ampere and Kelvin, these are named after scientists. Okay, actually this should have been K instead of capital K. Actually, you can see that the representation, the alphabet which is being used to represent it, it's being written in capital, isn't it? Kelvin, named after the famous English physicist Lord Kelvin. Okay. Similarly over here you can see ampere, named after the famous French physicist named as André-Marie Ampere. You can see that once again the symbolic representation is in capital A. Okay, so luminous intensity, candela, luminous intensity we are not going to be studying in the context of JEE in advanced physics curriculum, because this is a chapter, this comes under a chapter named as photometry. Photometry is excluded in the context of JEE in advanced. So but you should be recalling the name, okay, denoted by CD. And last but not the least, amount of substance in chemistry. You people have already studied about this, isn't it? So over here you can see that amount of substance is going to be measured in mole, and the unit representation is going to be MOL, isn't it, everyone? MKS system is equal to SI units. You can say like that, but actually it's already been given, right? Apart from, besides the 3 base units of MKS system, we also included 4 fundamental. The 4 fundamental we are trying to say this one, everyone: temperature, electric current, luminous intensity and amount of substance. We are also including 4 physical quantities along with it, and 2 supplementary units which are going to be radians, steradians, which is going to be measuring the plane angle and the solid angle. Okay, so that's what is the difference in between MKS. But yes, if you are talking about the fundamental quantities, then definitely they are going to be the same. There are no such difference in that. Once again, we are using meter, kilogram, second over here as well, which we were using in the MKS system. I hope it's clear. If yes, give a thumbs up. Let's proceed. Let's try to know about these, everyone. Okay, so these, from there itself, from these units, from these physical quantities itself, we can derive the dimensional formula of any derived quantity, isn't it? Like force, acceleration, then velocity, speed, isn't it? Electric field, magnetic field, and all the other quantities existing in your physics curriculum for JEE Main Advanced will be derived from this 7 existing physical quantities. Okay? This is a very easy thing. And if you're talking about the conversion, you can convert the values accordingly. Okay? So now based upon you can convert the values, we are coming to the conversion part as well. Someone asked me a question based upon it, if I can recall. So we are going to be discussing about that conversion as well. The conversions. So these you can say that if I talk about these systems, okay, starting from FPS, CGS, MKS, they can be interconverted. That means you are trying to say that this FPS can be converted into CGS, CGS can be converted into FPS. Similarly, I can convert CGS into MKS, CGS can be converted back to MKS can be converted back to CGS, isn't it? And the last but not the least, this MKS can be converted to FPS and FPS can be converted back to MKS. So that's what they are trying to say over here. Okay. Same thing goes for the conversion in SI system as well. All the 3 systems can be interconverted to MKS and MKS system can be converted to the other 2 systems. And similarly, I can say that all the 3 systems like FPS, MKS, CGS can be converted to SI and SI can be reconverted back to the existing 3 systems. So this is a very easy and interesting concept. I believe that you people have been blindly doing it. Blindly doing means subconsciously you are doing this conversion, but you don't know that. Because in 9th and 10th you are having some calculations, especially the CBSE and ICSE students. They have been doing hell lot of calculations in their class 9th and 10th science, but they don't know this is a conversion which they are doing it. Okay. So we'll try to know about the conversions as well over here. Okay. So the next comes over here, you can see that defining of the, you can see over here that defining a base unit, we are talking about the fundamental unit or standard for a physical quantity, the following characteristics. These are the following characteristics, isn't it, which must be considered. They have to be well defined, isn't it? They have to be you can say consistent. So that's what they are trying to say, that that's invariability. So they have to be constant over there, and accessibility means they should be easily accessible, easily available, they are trying to say over here. Reproducibility means they can be reproduced, and convenience in use. So these are the 4 characteristics which any fundamental quantity should be following over here. So now you can see that now we can classify the units accordingly. Okay. We have already discussed about there are 2 types of, on the basis of dependency, we can classify physical quantities into 2 aspects. One is the fundamental, another one is the base, isn't it? Now, how we are going to be classify the units? So you can see over here that fundamental or base quantities means what are these? These are the units which are associated with the fundamental physical quantity, isn't it? Which I've already discussed in the previous slide, if you can recall. So what is this? The units of fundamental quantities are called base units. In SI, there are 7 base units which we have already discussed, right? There are 7 base units which we are going to be having. And derived units over here which is being given. The units of derived quantities or the units that can be expressed in terms of the base units are called as derived units. So in other words, they are just trying to say that those units, the units associated with the derived physical quantities are going to be known as derived units. Okay, everyone? I hope it's clear. If yes, give a thumbs up, hit the like button. Everyone, I just want to know about your response related to this, such that we can do the conversion in the upcoming context. Don't try to talk anything unnecessary over here. Try to focus, everyone. Okay, so let's proceed to the next context, everyone. This is a very easy concept. Okay, so now you can see that these are the fundamental units, the one which is being depicted over here. What are these? Unit of speed is unit of distance by time. You know that speed is distance by time, isn't it? That's what it's being given. That is meter per second, isn't it? Some derived units are named in honor of the great scientists which I've already mentioned, like electric current with ampere, capital A, temperature, Lord Kelvin with capital K. That's what they are trying to say. If you are trying to write down the unit which is being named after any famous scientist, the first alphabet has to be capital letter, okay, over here. So now you can see that unit of force is equal to Newton, unit of frequency is going to be Hertz, and etc. That's what they are trying to say in this context. So supplementary units, so this is what is going to be derived units, right? So this is an example. Speed is a derived unit. Got it? Similarly, velocity, acceleration, force, electric field, magnetic field, pressure, work done, energy, isn't it? Then electric flux, magnetic flux, etc., etc. All of them, they come under derived quantities, okay, derived units. And the units are going to be derived units. So there is a derived quantity. So in short, I will say, in short, I would like to say you one thing, that if I'm having, let's say, a fundamental quantity, if I'm having a fundamental quantity, let's say over here, the unit associated with the fundamental quantity, the unit of the fundamental quantity is going to be known as the fundamental unit. Okay, everyone. And if I just try to take derived quantity, if I want to consider a derived quantity over here, everyone, so in that case, the unit is going to be known as the derived unit. So that is what they are trying to say, everyone. That's what they are trying to say over here in this context. Okay, I hope it's clear. So now comes the supplementary unit. Supplementary units, I said, right, in SI system there will be extra 4 units, 4 physical quantities associated, which are temperature, isn't it, amount of substance, luminous intensity, and electric current. Along with that, there will be 2 supplementary units. So there come supplementary units over here, if you are able to see in this context, that in international, see this, read this statement, international system SI units of 2 supplementary units are also defined, isn't it? They are also defined. That's what they are trying to say. And example, these are radian, which is the unit of plane angle, isn't it? Which we have already discussed before while teaching basic mathematics. Those who can recall radians, they can give a thumbs up, everyone. Those who can recall radians, they can give a thumbs up over here. Okay. So you can see that radians for plane angle and steradian for solid angle over here, isn't it? That's what we have already discussed about radians. We have been using it in vectors, the conversions, we have been doing it, right? 60 degree pi by 3, isn't it? Then 30 degrees pi by 6, 120 degrees 2 pi by 3 rads. We know the conversion. I've already mentioned the conversion, isn't it? So the same thing we are trying to do it over here as well. So that's what these units come under supplementary units. So radian, you can say that 1 radian is the angle subtended at the center of a circle by an arc. So you can say that it's equal in length to the radius of the circle. What they're trying to say, that you know, if I just try to construct, let's say we are trying to construct an arc, isn't it? That's how an arc will look like. A slice of pizza. Next time whenever you are going to be having a pizza, you can just recall this concept, because this concept is very, very important. That's an arc, and this arc is subtending some angle of theta at the center, isn't it? So this theta, this is going to be what? The length of the arc. Length of the arc, you know that. And if I say that this radius, this is the radius of the arc. R stands for the radius of the arc. So based upon this, I can write down, if I say that the length of the arc is given by the symbol L, capital L denotes the length of the area over here. So I can write down that L is going to be equivalent to R times of theta. So theta can be written as the ratio of the length of the arc to that of the radius. That's what they are trying to say. See this thing, at the center of a circle by an arc of equal in length to that of the radius of the circle. That's what they are trying to say in this statement. Okay. So now steradian, that's the unit, supplementary unit of solid angle. So solid angle is going to be discussed in the chapter named as electrostatics in your class 12th JEE in advanced curriculum. Over there you will be able to find out that Gauss law, a theorem which is used to calculate the electric field for symmetric objects, and in those cases the solid angle interpretation is going to be used. Okay. So now you can see over here that steradian, what is steradian? One steradian is the solid angle subtended at the center of a sphere, isn't it? By that surface of the sphere which is equal in area to the square of the radius of the sphere. That's what they are trying to say. So you can imagine the concept of solid angle over here as well. They are just trying to say that, just like the way I wrote down this equation over here, isn't it? The same thing we can imagine that a sphere, if I just consider a sphere over here, if I try to extract some part, some infinitesimal element from it, it will be in the shape of a cone. I will be getting some cone having some apex angle, isn't it? So that's what they are trying to say, that now that apex angle of the cone is going to be known as omega, which I will be calling it as your solid angle. Solid angle, you can write it down in a similar way. That is going to be nothing but 4 pi r square, which is the surface area of a sphere, to that of the square of the radius. So I will be getting it as solid angle is going to be 4 pi steradians, isn't it? That's what I will be getting it over here. So that's what they are saying, isn't it? So you can see that at the center of a sphere, by that surface of the sphere, which is 4 pi r square, which I wrote it down, which is equal in area to the square of the radius. So I am dividing it with the square of the radius. As a result, I am getting 4 pi to be the solid angle over here, isn't it? So you can say that 720 degrees, right? 4 pi is going to be equivalent to 720 degrees, 360 plus 360, isn't it? Those who can imagine this, they can give a thumbs up and hit the like button, everyone. Bataiye sab koi. I hope you are getting the concept of solid angle. So this omega over here, the one which I wrote it down, it as omega. This theta is the plane angle, everyone, isn't it? Theta over here is the plane angle, which I wrote it down over here. On the other hand, this omega, this is a Greek, you know this ohm. Don't call it as ohm, everyone. Don't call it as ohm, okay? Ohm is the SI unit of electric resistance, we know that, but that's a Greek symbol that's known as omega, okay? So this is omega, everyone. So this is nothing but your solid angle. So you can imagine it to be the apex angle of the cone if you are trying to extract some part from a sphere, isn't it? So that's what it's all about, nothing else. Okay, I hope it's clear, everyone. So let's move to the next context. These are your supplementary units which you have to recall. Okay, so now comes the next type of unit, improper units. That's the last type of units, everyone, improper units. So what are these? You can see. So these are some improper units. We use this, but actually we use them rarely. We are not going to be using them on a regular basis. So what is it all about? If you can see that these are the units which are not of the same nature as that of the physical quantities for which they are used. Example, kg weight, kg weight. So now kg weight, you will be finding this kg hyphen weight is nothing but kilogram weight. And where are we going to be using this? Where are we going to be using this? In order to understand the concept of spring balance and weighing balance, the measurement is going to be done in kg weight. Okay, that's once again, that's an improper unit of force, you can see. So which is an improper unit of weight? What is weight? Weight is force itself. So always remember one thing, you will be encountering with these terms once you start Newton's laws of motion over there. In the concept of spring balance, weighing balance, the measurement by these instruments will be done in the unit which is an improper in nature, and it's known as kg weight. Okay, these are the improper units of force. Weight is a force, isn't it, everyone? Yes, kgf, yes, you can say, Midula, kgf is also like that itself. Kgf is kg weight itself. Kg force they are saying, okay. That's kg weight we are trying to say, got it? So now the next is going to be, here kg is a unit of mass, but it is used to measure the weight. So these are the improper unit. Another improper unit is there as well, that is horsepower. Those who are aware about this term horsepower, they can give a thumbs up. And where it is used, some of you people are dreaming to become automobile engineers, isn't it? Or aerospace engineers. In that aspect, you will be encountering this term HP. And some people are already fond of Formula 1, isn't it? So Formula 1 in that case, if you can recall, all the racing cars will be having, or supercars I will be calling it as, like Ferrari, Lamborghini, BMW, their engine specification will be given in HP. That HP is nothing but the horsepower, exactly. So once again, the other unit which you can use it, that's going to be horsepower, isn't it? So this is going to be another improper unit of power. I will write it down. Isn't it? Okay, so I hope it's clear, everyone. So now you can see that units of some physical quantities in different systems. So you can, there's a tabulation over here. Very good, Padma Sri Rangan. You want to become a space engineer. That's really great of you all, isn't it? So now you can see that units of some physical quantities in different systems, isn't it? So in different countries, you can see MKS is used in France, FPS is used in Britain, Great Britain. That's England in the end of the day, everyone knows that, right, isn't it? And CGS once again is used in France itself. But SI we are going to be using it in India, okay? Until unless you appear for Olympiad examinations, especially International Physics Olympiad examination, over there you will be having the units representation in these forms, CGS, FPS, MKS will be asked, but it will be very rare to observe, isn't it? So now in this case, what's being given? Fundamental, isn't it? Length, mass, time. Derived is going to be force, work, energy, power, isn't it? So you can see that these are the representations, unit representations in CGS. MKS, these are the unit representation in MKS, isn't it? And for FPS, these are the units representation in FPS. I hope it's clear. So you can see that force will be measured in dynes. So you need to recall these values. In CGS, we can measure. There's a conversion as well. We are going to be knowing about the values. Okay. We are going to be knowing about the values, everyone, one after the other. In the upcoming context, we should be knowing about the conversion of one type of unit to the other, isn't it? So that's why you should not be worrying about anything, that we are going to be doing the conversion. And for Newton, you can say it's for MKS, and Poundal is going to be for FPS. So these are the three units in three different systems of unit associated with force. The next comes over here, that is work or energy. In CGS it will be ERG, urge I will be saying, and in MKS you know that joule. Even in SI system, the unit of force is Newton and the unit of work done or energy is joule itself, okay? But over here in the case of FPS it will be foot-poundal, okay everyone? Now for power, this has to be urge per second, because you know that power is energy per unit time, isn't it? That's how we can write down the unit very easily. So that's what I am trying to write down. This is going to be watt W for MK system. Same, you can consider it for SI system as well, where we are going to be measuring power in terms of watt, named after the English physicist James Watt, isn't it? The inventor of steam engine, engineer you can call it as him as, okay. And this is going to be foot-poundal per second, which we are going to be representing it for FPS system. Right everyone, I hope everyone's getting what I'm saying. If yes, give a thumbs up. Don't try to chat unnecessary things over here. It's my humble request to each and everyone. College is going to be starting after tomorrow itself, right, isn't it? Isn't it everyone? What else? So I hope it's clear. If yes, give a thumbs up, hit the like button. This is a theoretical aspect because we need to know certain theories associated with this concept. Then only we can think about solving problems in the upcoming day, which is tomorrow. Right everyone? Okay, so shall we proceed? Okay, next is going to be, you can see conversion factors. Now most of the people were thinking, how are we supposed to perform the conversions, right, isn't it? So there comes the concept of conversion factor. Okay, this is a very, very important concept in JEE Main, in chemistry, especially in both in physics and chemistry. This is also applicable for chemistry as well. This is also applicable for chemistry as well. So what is the conversion factor we are trying to say? So to convert a physical quantity from one set of units to the other, the required multiplication factor is known as the conversion factor. Okay, so obviously 1 Newton is equal to 10 to the power 5 dynes. I would like to prove this thing to you in the upcoming context. Okay, so you require the equivalence of 1 unit in one system is equivalent to a certain numerical value in the other system of unit. That's what we are addressing it to be as conversion of unit, isn't it? Okay, Varshit Reddy, great to hear it. So now you can see that what we have to do, magnitude is the most important thing. Magnitude of a physical quantity is going to be equivalent to numerical value into unit. Okay, magnitude is going to be constant. Always remember one thing, if I try to perform the conversion, this magnitude is going to be constant. It's not going to be changing anyone. Okay, so now you can see over here that while converting from one set of unit to the other, the magnitude of the quantity must remain the same. This is a very, very important statement, worth 1,000 stars. If you really want to perform the conversion, isn't it? This is going to be a very important statement. That is, for converting one set of unit to the other, the magnitude of the quantity is never going to change. Okay. So now you can see that this formula, you are going to be using it for the conversion of system of one unit to the other. That means N1U1 is going to be equivalent to N2U2. So what I can say, based upon this formula, if I am writing down N into U is equal to constant, isn't it? So can I say that this N is inversely proportional to U? Can I write down those in the favor of this equation? The one which is already being listed over here, N is inversely proportional to U. They can raise their thumbs up. They can raise their thumbs, everyone. I'm waiting for it. So now, can you tell me one thing, everyone? What will be the nature of the graph? If I try to plot a graph, let's say, this is a previous year JEE main question, everyone. If I try to plot a graph in between N and U, isn't it? What is N over here? You can see numerical value, U is the unit. If I try to plot a graph in between N and U, what will be the nature of the graph? Let's see whether you are able to recall graphs which I have taught to you all. What will be the nature of the graph? Say everyone. Let's see. What do you think, everyone? Negative slope नहीं पातुरी जी, negative slope नहीं होगा. Nature of the graph बताइए, straight line होगा, parabola, hyperbola, what I will be getting, ellipse, circle. In terms of coordinate geometry, in terms of conic sections, you people need to answer it. Right? In terms of conic sections, you all need to answer this. Negative slope, nope. Very good, Srikar, very good. Srikar is correct. Srikar Boditi is correct. Rectangular hyperbola. I said right. That's why that means you people are not studying. You people are still enjoying after your class 10th results. I know that you people have done very well. You people have scored outstandingly well in your class 10th examination. That does not mean that you people are going to be leaving to study, because this is a curriculum which requires a lot of concentration. You need to solve questions as much as you can. You need to study the concepts on a regular basis. Then only you can attain success, attain glory in the end of the day. Isn't it? If you really want to become the 3 people whose photographs are being embedded on the back side of my t-shirt, you really need to work very, very hard. They really have done extraordinarily well. Securing AIR1 in JEE Advanced, JEE Main and NEET is really extraordinary. I hope you are getting this. Isn't it? So I believe that you all should be starting to study, because anyways your college will be getting started maybe in the upcoming week or next to next week. But the most important thing which I would like to say, that you should be prepared for the college. Okay. So now the next is going to be, you can see, so now there is an example over here, that is the numerical value is inversely proportional, the one which I have said to you. So 1 meter, see now the conversion of 1 meter, that's representation in SI, needs to be converted to 100 centimeters CGS. it needs to be converted into FPS, which is 3.28 feet, and now this is equivalent to 39.4 inches. Okay, so this is going to be the conversion of 1 meter into FPS into feet and inches. Got it? So that's what I would like to say over here. So this is how the conversion will be looking like. So now before starting dimensions, let's try to solve this, everyone. Can you tell me the value of it? What do you think is going to be convert 1 Newton into dynes, where you can say that Newton is the SI unit into dynes? Can anyone tell me the value of it? I've already said it in between while demonstrating this lecture session of yours. Okay. So what do you think will be the value? Let's see who will be saying the answer. So how to perform the conversions? Which formula are we supposed to use? N1 U1 is N2 U2, isn't it? What is N1? N1 is the numerical value, N2 is the numerical value, U1 is the unit of system 1 and U2 is the unit of system 2. Very good, Grishmant. Very good. So now over here they have given you, so you are trying to convert newtons into CGS. So let's say the first system of unit in this, the first system of unit over here is SI, because you know that Newton is the system of unit which they are asking us to convert to CGS. What is the second system of unit over here? You can write down the second system of unit. That is CGS. So what is N1? Can anyone tell me the value of N1? Write down over there in the chat box. What is the value of N1, everyone? चलो सही बोल रहे सब कोई? I think so. Already got the answer previously, right? Grishmant was the one to give me the correct answer. What is N1? Write down the value of the N1 over there. What do you think is going to be N1 in this question? N1, everyone, 1. Very good. So N1 is 1, isn't it? And what about U1? U1 is going to be Newton. 1 Newton is kg meter per second square. You know that, right? Forces, mass into acceleration. U1 is Newton. You know that 1 Newton is equal to 1 kg into 1 meter per second square. कैसे आ रहा है? F is equal to ma. F is equal to mass into acceleration, isn't it? Where this expression is coming from? You know that forces, mass into acceleration. This formula you have been knowing since your class 7th standard, isn't it? Forces, mass into acceleration. What is the SI unit of mass? Kg. What is the, right, isn't it? What is the SI unit of mass, everyone? That is kg. What is the SI unit of acceleration? That is meter per second square. So as a result, I can write down U1 as kg meter per second square, isn't it? That is going to be equivalent to what? They're trying, okay. So now let's try to write down N2. N2 is required to be found. And what is U2, everyone? U2 is going to be gram centimeter per second square, isn't it? Those are the favor of me writing down the value of U2, the expression of U2, they can give a thumbs up. U2 is going to be gram centimeter per second square, isn't it? So based upon this, what I can write down? That is N1 U1. So I will write it down it as 1 into kg meter per second square is going to be equivalent to what? That is N2 into gram centimeter per second square. So now we need to perform, isn't it? Yes or no? We need to find out the value of N2 over here. So let's try to convert this gram into kg. Can you write down 1 gram is equal to how many kgs? Write it down over there in the chat box, everyone. And hit the like button. Keep on hitting the like button as well. So what do you think, everyone? बताइए सबको क्या होना चाहिए? So you know that 1 gram is equal to what? We can write it down, everyone. We can write it down over here as 1 gram is 10 to the power minus 3 kg. Do you agree to this? Isn't it? 1 by 1000 means 10 to the power minus 3. And similarly, I can write down 1 centimeter is equal to 10 to the power minus 2 meters. Isn't it? So now just put the values over there. Then my expression will become what? 1 kg meter per second square is going to be equivalent to N2. Instead of gram, I will substitute this value, which is 10 to the power minus 3 kg, isn't it? Now instead of centimeters, I have to substitute this value, which is 10 to the power minus 2 meters by second square. So now you can see kg gets cancelled out, isn't it? Meters gets cancelled out, second square gets cancelled out, isn't it? So what we are left behind with? 1 is equals to N2, isn't it? 1 is going to be equivalent to N2 over here. Isn't it, everyone? 1 is going to be N2 multiplied by 10 to the power minus 5, isn't it? So what I will be getting? So as a result, I can say that N2 is going to be equivalent to 1 by 10 to the power minus 5, which is 10 to the power 5. So what do you think the answer is? That means I can say 1 Newton is 10 to the power 5 dynes, isn't it? And if I want to write down the reverse of it, what I will be getting? The reverse is going to be written as 1 dyne is 10 to the power minus 5 newtons. So that's how the conversion is being done. If yes, give a thumbs up as much as you can and hit the like button. I hope it's clear, everyone. You can see the calculation of it. What do you say, everyone? Yes, very good, Pavan Rama. 0.1 10 to the power 6. You can also convert into the power of 10 to the power 7 as well, 10 to the power 4 as well, isn't it? You can keep on converting that. It completely depends on you, isn't it? Okay, everyone, so that's how we can do the conversion. Okay, so now let's say if I ask you another question, if it's done, I will give you my question. Convert urge into joules. What do you think should be the answer? A few minutes back itself we discussed about urge, isn't it? So urge is the CGS unit of energy or work done, isn't it? Energy of work done, isn't it? So what do you think is going to be the value of it? Yes, Gautam, Ritesh, C, you are right, isn't it? So what do you think should be the answer to this question, everyone? What do you think we are going to be getting? 10 past 7. No, you are right almost, but some power is missing. Mridula. Mridula, you are writing down the wrong power. Power is something else. Check it once. What do you think it's going to be? So let's see. Once again, I would like to do. So Mridula is, Ammu 973 is correct. Yes, 1E2. Exactly, you are right. Jitendra is right. Correct, everyone. So now, the first system is ERG, isn't it? And what is the second system? The second system which we are having, that is joule, isn't it? So you know that what is 1 joule? Let's try to write down the not the CGS representation, you can write it down, the SI unit representation, we will try to write it down, okay? Yes, correct, 10 to the power minus 7 is right, this is the right answer. So 1 joule is, you know that work done is force dot displacement, isn't it? What is work done, everyone? With this formula itself we can derive it, isn't it? Work done is force dot displacement. Work done, that means it's going to be in joules, so you can say mass into acceleration into displacement, isn't it? That's what I can say. Mass into acceleration into the displacement. ma into s मान लीजिए, s नहीं लेंगे, चलिए मैं x ले लेता हूँ, वो ज़्यादा बेटर होगा अंडरस्टैंडमेंट के लिए. So let us say f into x, x is a displacement, so I can write it down as m into x. So that will be 1 joule will be 1 kg meter square, isn't it, per second square. And what is going to be the CGS representation, isn't it? So I can say that 1 erg is going to be 1 gram centimeter square per second square, isn't it? Those who are in the favor of yes, they can give a thumbs up and hit the like button. Okay, so let's try to perform the conversion. So we are being asked to convert 1 erg into joules, isn't it? So N1 is 1, U1 over here is 1 gram centimeter square per second square, isn't it? Over here they have given us N2, we need to find out. That's the numerical value conversion in the SI unit, isn't it? And over here U2 is 1 kg meter square per second square, isn't it? So that's what we can write it down. So now let's try to perform N1 U1 is equals to N2 U2, isn't it? What is N1? N1 is 1 into, you can write down 1 into 1 gram centimeter square per second square. That is going to be N2 is required to be found. U2 is 1, isn't it, kg meter square per second square, isn't it? So you can remove this one for betterment. Okay? You can remove this one. You know, just you know the unit, isn't it? These are the units. So now we need to convert into N2, isn't it? So what we can do? Let's try to convert this. You know that 1 gram is 10 to the power minus 3 kg. The same things we are going to be using it over here. And we know that 1 centimeter is 10 to the power minus 2 meters, isn't it? So now what we will write down? 1 gram is 10 to the power minus 3 kg. Instead of gram, I am writing it down like this. But now we are having centimeter square. 1 centimeter is 10 to the power minus 2 meter. It will become whole squared. Okay, that's the only change which we are going to be having here. By second square, that is equal to N2 kg meter square per second square. So the second square will be cancelling out, kgs will be cancelling out, and over here I will be getting this as what? That means 10 to the power minus 3 into 10 to the power minus 4 meter square is equals to, isn't it, N2 times meter square. This m square will be also getting cancelled out. So what I will be having? So as a result of that, I am going to be getting the value of N2 as 10 to the power minus 3 minus 4, isn't it? Everyone knows the multiplication of the exponents. So I will be getting N2 as 10 to the power minus 7. So as a result of that, what we can say, everyone, I can say that 1 erg is equivalent to 10 to the power minus 7 joules, and the vice versa we can be reverted back once again over here and could be written as 1 joule is also going to be written as what we can write it down. You can write down 1 joule, isn't it? 1 joule is going to be equivalent to 10 to the power 7 erg. Like this. I hope it's clear. If yes, give a thumbs up, hit the like button, everyone. Okay, so understood, everyone? So 10 to the power minus 7 is the answer to this question. Okay. चलिए ठीक है. Everyone got the answer? Okay, let's proceed. Okay, so let's start our discussion on. Okay, so let's try to start dimension analysis such that tomorrow we can solve some dimensional analysis based questions. Okay, so let's start dimensions. We are having 6 minutes for this session, but we should be knowing what dimensions are. So now what do we understand by dimensions, everyone? So you can see that dimensions, now we have completed units. Now we have to understand dimensions. Okay, so what is dimensions over here? Dimensions of a physical quantity are the powers or exponents to which the base quantity are raised or expressed that quantity with. Okay, so any physical quantity, if I say, if I say x is a physical quantity. Okay, if x is a physical quantity which is a derived quantity. Okay, so it is a derived quantity. I can write down x as m to the power alpha या मान लीजिए a मान लीजिए, it's better to use simpler terms. So if I say that this is going to be m to the power a, l to the power b, t to the power c. So you can write down x as m to the power a, l to the power b, t to the power c, where a, b, c are the powers. That's what they're trying to say, that a, b, c, they are the powers. So this, in this thing, in this context, I will say a, b, c are the dimensions. A, B, C are the dimensions. That's what the first statement is trying to mention. Okay, I hope it's clear. The next is going to be dimensional formula. The dimensional formula of any physical quantity is that expression, just like the way I expressed it, right? So this entire expression, okay, fine. First of all, let's try to read the statement. Okay, so any physical quantity is that expression which represents how and which of the base quantities are included in that quantity. It is written by enclosing the symbols, just like the way I wrote it down, with square brackets. You need to denote everything. Okay, got it? With appropriate powers in the square brackets like this. These are square brackets or close brackets, you can call it as, isn't it? So, okay, dimensional formula of mass, you can also write, you can also express the dimensional formula of the fundamental physical quantities like mass, length, time. So you can see mass, you know that m, isn't it? So it is going to be denoted by m to the power 1. L0, T0 means, you know that length and time will be nothing, will be unity in the aspect of mass. That's what they are trying to say it over here. And that of speed is going to be distance by time m0 L1 t to the power minus 1. How we are getting this? We are using the formula of, we are using speed is what, everyone? Speed is distance by time. So that's what we are trying to write down. You know that speed is, v is, you can write down v is going to be x by t. So you know that what is the dimensional formula of displacement? Means distance, let's say that is L. We'll write it down like this, and for time I will write it down like this. As a result of that, this will be written as L t to the power minus 1. So that's what they are trying to say, L1 t to the power minus 1. So obviously I said that any physical quantity, it can be a derived, it can be a fundamental, is going to be represented as m to the power a, b, l to the power b, t to the power c. So in this aspect you can see that there are no such terms associated with mass. So I can also write down this as m0, isn't it? m0 l to the power 1 t to the power minus 1. That's what they have written it over here. Okay, so that's what your dimensional formula is all about. Now comes the next context, that is dimensional equation. Okay, I hope it's clear, everyone. If yes, give a thumbs up, hit the like button. Let's move to dimensional equation. The same way you can write it down, that the equation obtained by equating a physical quantity with its dimensional formula is called a dimensional equation. For V, we have already discussed, this is how you can write down the dimensional equation, okay? And for force, it is mLt minus 2. I will discuss this right now, isn't it? And mLt minus 2 is the dimensional formula for force, and the dimension of force are 1 in mass, 1 in length, and minus 2 in time. You know that force is mass into acceleration, isn't it? And you know that force can be written as mass into acceleration is what? Velocity by time, isn't it? So, and you know that velocity is what? Velocity is displacement by time. So I can write it down as x by t by t. That's a result of that. First of all, see, there is no need to recall the dimensional formula of all the fundamental quantities associated in your textbook, because gradually as the chapter progresses, you will be learning the dimensional formula one after the other. You will be getting to know about each and every derived quantities. So that's why there is no need to remember this. Only the basics you should be recalling, nothing else, okay? So force can be written as what, everyone? So you can write it down it as mass into displacement by time square, isn't it? So if I want to write down the dimensional equation of force, how are we supposed to write it down? So this is, you can write down force like this is going to be equivalent to m. For displacement, m to the power 1, mass m to the power 1, displacement it is l to the power 1, and for time, time can be brought to the numerator from the denominator section, it is going to be t minus 2. So that's how you are going to be getting this as ml t minus 2. I hope it's clear, everyone. So this is what dimensional equation is all about. Tomorrow we are going to be discussing about the application part of it, and we are going to be solving some questions. There are a lot of questions, PYQs as well. Okay, so based upon this, I believe that everything will be clear till now. If yes, give a thumbs up, hit the like button. We are about to start applications for tomorrow. I believe that that's going to be your last lecture session for your bridge course, IIT JEE 2027 aspirants of this year 2025, isn't it? So if you want to say anything, you can say. Thank you very much for today. Those who want to say anything, they can say. If you can ask anything, whatever. Now I am here to answer your queries. All your queries will be answered, one after the other. So tomorrow I want 100% participation and 100% likes from each and every student, whomsoever are attending that session. Tomorrow's last, okay. Yes, I think so. Tomorrow is going to be the last session, I think so. Very good, Ramanuja. Anything else you want to ask? So you can meet me over here in Hyderabad, Madhapur, Vagdevi campus. I will be there itself. If you really want to take certain tips from my side, isn't it? Anything else you want to ask, you can ask everyone before your maths class gets started. Yes, hello. No comments on that, Nikhil. And I think so previously as well, some person asked me that we cannot comment on these things, isn't it? It's the same thing I said, Lord Brooke. Anything else, anyone? College will be getting started. Tomorrow we are having class Karthikeyan. Okay, tomorrow we are having the session. Okay, so we can have a discussion tomorrow about all these things, isn't it? We can have all the discussions about all these things for tomorrow. College will be opening once this bridge course ends, isn't it? College will be opening once this bridge course ends. I am from Ranchi, Jharkhand, Srinu. What else you want to ask? Yes, R.D. Sharma is the must book in order to know the basics of maths. That's I've already mentioned it previously. But as the JEE made an advanced curriculum of mathematics will be progressing, you will be knowing everything. That's a very difficult thing to do so, Lakshmikant. That's going to be a difficult thing to do, indeed. Of course, Nikhil. Tomorrow, Sriya, I think so tomorrow it will be ending. Tomorrow it will be ending. Okay, fine. Thank you very much. Thank you for this session, everyone. If you like the session, like it, everyone. Hit the like button as much as you can. And don't forget to subscribe our channel. So departing right now, it's Avinav Banerjee for you. We'll be back once again with dimension analysis for tomorrow's session, which will be the last day of your bridge course.